We'll try and go through this relatively quickly given the time constraints. So we talked tonight about the C&D, or cleaning and disinfection process. Typically, when we talk about cleaning and disinfection, we talk about 3 steps. This is somewhat dependent on which chemistry you use, but traditionally we talk about the dry clean, then the wet clean, and disinfection step. So dry cleaning basically is the removal of gross organic material. And when I say gross, I don't mean as in ooey or icky. I'm talking about large amounts. So this is your scraping, sweeping, brushing, or blowing. Getting rid of the vast majority of the organic material in the facility, in the area that you're cleaning and disinfecting. And then after the dry clean, the recommendation or the protocol that's recommended is proceeding to a wet clean. Basically, wet cleaning is first of all, it's an application of a surfactant or a degreaser followed by water washing. Again, there's a little bit of difference in depending on the chemistry you're using on this, but that's traditionally how it's looked at. So this is your soap. This is your different cleaners that are out there that you are using to rid the surfaces of any organic material that is left from the dry clean that did not, wasn't removed. This can be done, the washing part after you've applied the surfactant or soap, can be done either with low pressure or high pressure. When I talk about low pressure, I'm talking about garden hose, normal city water. High pressure, of course, is with pressure washers. Foaming is recommended. Anytime you apply a surfactant or a disinfectant, there's many ways you can apply it. You can apply it just as a spray on, or fogging is another technique that's used, in agriculture. But if you really want to get the best recommendation, we as biosecurity experts, we recommend foaming. I'll get into the reason why on that in a second. Warm or hot water typically increases efficiencies of the chemicals of the degreaser, the surfactant, as well as it allows that emulsification of the organic material there to happen easier. So, for example, here's a couple pictures that kind of show you from a dry cleaned barn there. That door still has biofilm or organic material on it, and then it has been wet cleaned up. The prime example again, water lines in a barn. You can see there's still dander there that didn't get blown off, and then after your wet clean, you have there's the removal of all the organic material. So then we come to the disinfection step. After removal of all visible organic material and there's no standing water left, disinfection can take place. The reason that we don't want really any large amounts of standing water there is because that can actually affect the dilution of the disinfectant. So if there's puddles or pools of water, and then I apply a disinfectant which is at the correct dilution, that standing water is going to further dilute that disinfectant to, which would reduce its efficacy. Components of disinfection and the specific disinfectant you use include contact time, dilution, the coverage rates. We're also going to talk about log reduction, which is basically sanitizing versus disinfection. You're going to hear those terms. You may hear those when you're dealing in this cleaning and disinfection realm. Bactericides, virucides, and fungicide, those kind of claims. We're also going to talk here shortly about the human and animal health aspects of the different chemistries out there, as well as the environmental sustainability and the material compatibility. Is that chemical safe to use on the surface that the material that you're using it on? So when we talk about contact time is the time that the surface needs to stay wet for that disinfectant to truly be effective. So this typically ranges anywhere from 3 minutes to 20 minutes, depending on the chemistry. If you read the fine print on Lysol wipes, for example, it's a 10-minute contact time. So in order for that Lysol wipe, that disinfectant, to truly be effective, that surface needs to stay wet for that 10 minutes. During the COVID experience, I mean, it made me question a lot when I'd go to the grocery store and the cashier was spraying the conveyor with a quat or a disinfectant and wiping it immediately, and the surface was wet maybe for 7 seconds. Really, we're not achieving very much through that process. As I said earlier, foaming increases the surface adhesion and increases the contact time of the disinfectant. How that happens is those air bubbles that are created in the foam, they actually act as an insulator, and so that allows that disinfectant to stay in a liquid state longer than if it was actually just sprayed on. In addition, foaming, you actually can see what's covered. That white foam sticks out on the surface, that you really can tell what you've covered and what you haven't. And foaming also gives you actually a greater coverage area. The amount of solution goes further because you're spreading it thinner on the surface. Dilution. You have to be cognizant of ready-to-use disinfectants versus concentrates. So the typical disinfectant you buy in the hardware stores or grocery stores, whether it be in a spray bottle or in a wipe form, those are ready to use. There's no dilution needed. Where concentrates, and this is what we see mostly in agriculture, they're a concentrated form of that disinfectant. They need to be diluted with water. How much water is added to the disinfectant concentration to make that in-use solution is the dilution rate. And typically it ranges anywhere from 0.4% to 10% as high as in some cases. So that works out to a ratio of 1 to 256 to 1 to 10. Also be noted, some chemistries have different dilutions dependent on the pathogen. Some pathogens are harder to kill than others, and so you'll notice that contact time or dilutions could be different. This is primarily in the states that they allow this. In Health Canada, you're really only allowed 1 dilution rate, but the contact times will actually change. Coverage rates. How much solution is required to cover the surface? Traditionally, most disinfectants cover approximately 100, and I forgot to put in here how much, but 125 square feet per gallon of diluted solution. I apologize for the imperial measurements. It's just, these are the ones that we kind of work with. But so 1 gallon of diluted solution that you've made up, spraying that on, or if it doesn't foam very well, it's going to cover that 125 square feet. Chemistries that foam well will cover more, as I said. You can get up to 250 or 300 square feet per gallon of diluted solution. Log reduction. You'll hear this term sometimes in the science of disinfection. 3 log versus 6 log reduction. So just to be, again, note, in order to really be classified as a true disinfectant, you need it's a 6 log reduction, and that translates to 6 nines is the easiest way to remember it. So a 99.9999% kill, where 3 log is again 99.9. This is also the general accepted classification between sanitizing versus disinfection. So sanitizers, when you hear the term sanitize, it's generally speaking to a 3 log reduction, and where disinfection is talking about a 6 log reduction. You'd think, well, is that really a big difference? Well, it can be when you're talking, especially with viruses. It's very little virus is needed to cause an infection. So when it's very important that you're getting that true kill rate that you're actually trying to achieve. And just of note, when a disinfectant gets its claim, its license to kill, if you want to call it, approval from Health Canada, or in the States, the EPA, all that testing that has shown the science of that disinfectant that it can kill is done at 20 degrees Celsius with no organic load. And as temperature drops, contact time increases to obtain the equivalent log reduction. So, for example, if a disinfectant has a 10-minute contact time at 20 degrees, typically it would be double that, or 20 minutes at 0 degrees, and again, further increases of contact time even under below 0. So again, you want to make sure that you're doing the best job you can to achieve the longest contact time possible. Bactericide, viricide, and fungicide claim. So disinfectants are tested against a range of specific pathogens, and these are listed either on the label, on the reference sheet of a disinfectant. Now, we're most, of course, concerned with avian influenza here tonight. Thankfully, avian influenza is not a difficult pathogen to kill. We kind of listed or regarded it as a wimpy virus. So thankfully, it's not that difficult to kill, again, if there's no presence of organic material. Some pathogens are actually recognized as hard to kill, i.e. polio 7 type number 1. It's generally accepted as one of the world's hardest viruses to kill. So disinfectants are allowed what they call a general virucidal claim, or a bactericidal claim, fungicidal claim, where they've shown to kill the really, really tough ones, and therefore it's accepted that they don't need to, test against, hundreds or thousands of other different pathogens. They have that general virucidal, fungicidal, or bactericidal claim. Human health issues. Traditional chemistries can have significant health warnings. So make sure you read the MSDS sheet and follow the label. Really encourage you to read the fine print on whatever chemistry you're using. They'll require, PPE, from gloves and goggles to masks and even respirators. Some of the chemistries out there are very nasty, and so just be wary of that. Environmental and material compatibility. Disinfectants can be harmful to the environment. So again, make sure you're aware of, in terms of disposal, overspray, that kind of thing. Disinfectants can also harm or damage certain materials, whether it be concrete. There are certain disinfectants that basically they eat concrete alive over time. Some of the, the metals, there's issues there. So again, follow the label instructions when it comes to material compatibility and disposal. If you are concerned about a certain, surface material and the disinfectant, damaging it, you can always, get that contact time, and then you can rinse it off if you really feel necessary. But as I said, the best thing that you can do is try and leave it on there as long as possible. So just spend a few slides here on disinfectant comparisons. I've just picked the major ones here, but there's quaternary ammonias, or quats they're known as. Typically, they have about a 10-minute contact time. Very narrow effectiveness. They're effective against the easiest of pathogens, and they have a very limited cleaning ability. There's really no surfactants in there, so that surface must be absolutely spotless before you want to use a quat. There are some human health risk and environmental concerns. The one plus about quats is they're very inexpensive. They're very cheap to use. Glutaraldehydes, glutes we call them. Again, typically a 10-minute contact time. They do have a broad spectrum kill, but the thing is with them, they have zero. Just like no cleaning ability whatsoever. So again, surface must be absolutely spotless. Even more so than the quat. Glutes are also there's some significant health concerns and cautions and environmental cautions as well. Cost-wise, they're about an average cost. There's some chemicals out there, chemistries that maybe use a combination of glute with a quat, or for example, I believe Synergize is that way. So they're trying to get kind of combine the two. Unfortunately, they still maintain some of those negative connotations even with that. Chlorine, bleach, we're pretty much all aware of that. Again, it's about a 10-minute contact time, very broad spectrum kill, no cleaning ability whatsoever. Again, that surface must be absolutely spotless. There are some human health risks and environmental concerns, but again, very inexpensive. Oxidizers, this would be something like a Virkon, for example. A 10 to 20-minute contact time, depending on the pathogen you're trying to go after. But again, it kills a broad spectrum of organisms. Some cleaning ability, actually, there's actually a cleaning ability test, and relative to the traditional older style disinfectants, Virkon is actually not that bad when it comes to cleaning ability. So it has a bit of an ability to clean even with the presence of limited organic material. Unfortunately, there are some concerns health-wise and environmental-wise, and material compatibility-wise. Somewhat costly. The one that Ashley referred to that we deal with is accelerated hydrogen peroxide. It's a relatively newer development in disinfection. It's actually a Canadian invention, actually, and it's a very fast contact time. It's only a 5-minute contact time using the concentrate, 3 minutes with the ready to use. Very broad spectrum kill, excellent cleaning ability. It really does way more so than Virkon even. It has the surfactants in there make it a real great cleaner as well as a disinfectant. And Iowa State University actually has some research on this where they were able to kill porcine endemic diarrhea, or PED, in a heavy fecal load, actually, something that no other real disinfectant can even think about doing. Because of those surfactants, it does have a great coverage area. The dilution is 1 to 40 for disinfection and 1 to 128 for sanitizing and cleaning. So you have a range of dilutions to make it cost effective. No PPE required and environmentally safe. It's actually the first disinfectant to have eco logo approval. Biodegradable, and as I said, it gives you an average cost comparison. Those pictures I showed you before, I actually cheated. Those were actually done with accelerated hydrogen peroxide, or the brand name here in Canada for agriculture is called Prevail. And that was actually just with low pressure water. So that overhead door was foamed on with Prevail, and then just not pressure washed, just rinsed off with a garden hose. And that's actually, believe it or not, that's 11 years of biofilm on that door. That was an egg layer barn that hadn't been washed very much. Same thing here. This was Prevail that just as a rinsed off. So anyway, a summary. 3-step process, as I said. Typically, you can get 1-step cleaners and disinfectants like the accelerated hydrogen peroxide that can shorten that. But typically, the surfaces must be clean of organic material prior to disinfection. Most importantly, read and follow the label instructions, including that fine print. It's going to tell you that contact time. It's going to tell you the proper dilution. And then lastly, check those MSDS sheets for precautions, i.e., do you need PPE? Does it need to be well ventilated? Do you need a respirator? Is there any special concerns in terms of handling that product? That's about it I have.